Hello and welcome back to our video class here at CSEC Math Tutor. In this lesson, we are talking about distance time graphs, and our objectives are to define and use speed and average speed, to correctly interpret a distance time graph, and to calculate speed using rise over run. We will also be looking at some CXC questions to give you some experience with them. So when we say speed, we generally mean the distance traveled per unit of time. Speed also can be defined as the rate of change of motion. So for that matter, speed in a general sense is a scalar quantity. We can use velocity, which is similar to speed, but velocity tends to mean speed in a specific direction. Now, speed can be calculated using the formula S equal d over t, or we say speed is equal to distance over time, distance divided by time, or we may use it in the form rise over run. You may recall that rise over run is one way in which we calculate the gradient of a straight line. Average speed is calculated as the total distance divided by the total time. Now let's look at how we can interpret a distance time graph. Typically, a simple distance time graph is drawn this way. We have our vertical axis, which contains our distance, and we have our horizontal axis, which has our time. Notice the anatomy of the graph. We have a line slanting in this direction, then we have a flat line, and then we have another line slanted back. So here we go. In a distance time graph, and you will notice a distance time graph, it will always have km or meters or miles, whatever the unit of distance is on this axis. And this axis will have time in either seconds or minutes or hours. So this line here, whenever we have a slanted line here, it means that the object, whatever it is moving. So it's going somewhere, it's moving. When we have a flat line in this type of graph, it means that the thing has come to a stop. And when we have the line going in the opposite direction, it means that the thing is returning to where it came from. So going, resting, returning. This is the anatomy of the distance time graph. The slanted line in this direction means going. The flat line means that the thing has stopped or is resting. And the line going back is the line moving in the opposite direction as to going back to where it came from. Now let's talk about this in terms of two vehicles. There's a car represented by the broken line here, and there's a van represented by the bold line here, unbroken line. So two vehicles left different places. The van left at 9 and the car left at 9:30. Now, importantly, when you're doing a distance time graph, you need to do something important before you start answering any questions. You need to look at the scale that is used on your graph. So on your y-axis here, notice that each of these small boxes represents 3 miles. It says distance in miles. Each of these small boxes represent 3 miles. So 3, 6. Now, on your x-axis, each small box, notice that from here to here is 30 minutes. So each of these small boxes would naturally represent 10 minutes. So 10, 20, 30, etc. It is very important that you look at your scale and understand it before you start running into and answering your questions. So let's look at the van. The van would leave at 9 o'clock, travel for some distance, then stop. Then it travels again and stops. Now, at this point, it has reached where it's going. And then now this line would say that it's coming back or coming back home to where it started from. The car, on the other hand, would start at 9:30 and would travel all the way to the place where it's going. It stops once it gets there, of course, spends some time, then travels back. On its way coming back, it stops, spends some time there because it stops here, and then it continues on its journey. So the Van left out before, but took a longer time to complete the total journey. Starts at 9 o'clock and came back at 14:30 hours or 2:30. And the car would have left at 9:30 and finished the journey, the whole journey here. So you can look at the graph and understand that the slanted line means that the thing is moving, the flat line means that it has stopped, and the returning line here means that the car, the van in this case, or whatever, the car is coming back home. Now, on this part of the journey, the thing is moving. It's moving here. It's moving here. This part of the journey, it has stopped. This part of the journey, it has stopped. Hopefully that gives you a good idea of what we mean when we're talking about the graph. So a slanted line means that the thing is moving. The flat line means it has stopped. And the line heading in the opposite direction means that it's returning to where it came from. Now let's look at two questions from CXC that we can answer and put these into perspective with calculations. Here we have one, and it says the distance time graph below describes the journey of a train between two train stations A and B. A is here and B is here. Answer the questions below. Well, pretty much answer the questions below. So for how many minutes was the train at rest at B? So notice here that the train has moved, started at A, continues, and then it stops here. So the train is moving here, and then it has stopped here. It's not moving. So for how many minutes was the train at rest at B? Now let's look at our scale. Notice on our scale, on our x-axis, from this point to this point represents 20 minutes, time in minutes. So each small box here represents 10 minutes. 10, 20. On our vertical axis, each small box here would represent 20 kilometers. So from here to here is 20, from here to here is 20, so we're going up 20, 40, etc. 20, 40, 60, 80. So we can answer our questions now that we understand our scale. For how many minutes was the car at rest? The car was at rest all of here. All of this section, the car was at rest. Now, how many minutes do we have here? The minutes that are here are between 40 and 60, and so we can answer that question easily by saying the total time here is 20 minutes. So 10, 20 minutes. Next thing, we are asked to determine the average speed of the train in kilometers per hour on its journey from A to B. Now this is A and this is B. And to find the average speed, what we're going to do is to calculate the gradient of this straight line. We calculate the gradient of this straight line using rise over run. Or in this case, it's speed over distance over time, which is the same thing as rise over run. So we can say that in answering part 2, the speed is equal to the rise over run or the distance over time. Distance over time. Now the distance here from here to here, notice 20, 40, 60, 80, 100. So we have 100 kilometers. And the time is 20, 40, 60, 20, 40 minutes. Now, I'm saying it again to make sure that you pay attention to your question. So if you divide this as is, you are going to notice that you're going to get 40 into 100 gives you 2.5. And 2.5 here would be kilometers per minute. But notice that the question says, calculate the speed in terms of kilometers per hour. So because this time is in minutes, we need to write it as a fraction of an hour. So we're going to write instead 100 divided by 40, and an hour is 60 minutes. And so we're going to do it this way. We can do a simple division here, which means we're going to divide 100 divided by 2/3, which means that we're going to have 100 times 3 over 2. And that gives us 150 kilometers per hour. So it's very easy to make that mistake, to just divide the distance traveled here by the time. But pay attention, notice that the question wants it in kilometers per hour and not kilometers per minute. Next part of the question. The train continued its journey away from station A and B to another station C, which is 50 kilometers away. The average speed for that journey is 60 kilometers per hour. Calculate the time in minutes taken for the train to travel from B to C. So there's another station somewhere away, and we're asked 50 kilometers away, and we're asked to find the time that it takes to travel from B to C. Now let's write down the formula again. Part 3, speed is equal to distance over time. Now what is our speed? Our speed is 60. So 60 kilometers per hour is equal to the distance, and the distance is 50 per hour. And the time is what we need to calculate. We can do a simple cross multiplication here, and that will tell us that 60t is equal to 50. And therefore, t is going to be equal to 50 divided by 60. And that tells us that the train took 50 minutes. Because remember, there are 60 minutes make an hour. So 50 over 60 would actually mean 50 minutes. So the train takes 50 minutes to move from the place where it is at B to get to C. Now, the part 4 of the question says, draw the line segment which describes the journey of the train from B to C. Now, what do we know? It takes 50 minutes to get there. We are at 60 minutes right here, so let's count 50 more minutes. 10, 20, 30, 40, 50. So 50 minutes takes us here. And the distance is 50 kilometers away from this point. So let's find 50 kilometers away from this point. Remember that each one of these is 20. So we have 20, 40, 50. So we go across and we notice that our point should be there, 50 kilometers above this one. And we can simply put in our line segment to finish our question. So let's put in our line segment. And there we have it. And that would represent the completion of the journey. Let me put that in another color. That line would finish, would make sure that we have answered the question correctly. So that would be our line segment. And that answers this question. Let's move on to another one. Here we have the distance time graph below shows the 3-stage journey of a car traveling from town A to town C and then back to town A. So remember, we said a slanted line means that the car, in this case, is moving. The flat line means it has stopped. The slant line means it's moving again. The flat line means it has stopped. And then this line coming back means that the car is returning to where it came from. So it's moving here, it's moving here, and it's moving here. All right, let's try to answer our questions now. But before we do that, let's look at our scale. So on our y-axis, each box represents 10 kilometers, so 10, 1 centimeter to 10 there. And on this, our x-axis in terms of time, it says time of day. So this is 6, this is 7, that's an hour. So we notice that each of these would represent 4 boxes, so each of these represents 15 minutes. So each box on this section, each centimeter box represents 15 minutes. All right, let's talk about our questions. State the time of day at which the train arrived at town C. The car arrived at town C at this point in time, which is right here, that time. And so this is 8. Remember, each of these is 15 minutes. So this is 8:15 plus 15 more. That would be 8:30. and assuming it's AM, 8:30, and that would be our time when the train arrived at town C. Second part, calculate the total time in minutes for which the car stopped during the journey. So the car stopped here. Let me put that in another color to make it a bit more obvious. The car stopped here, and the car also stopped here. So we have two periods of 15 minutes here and another 15-minute period there. Remember, each of these boxes represents 15 minutes. So we have 3 times 15, and that's 45 minutes. So the car would have stopped for a total of 45 minutes. So half an hour here and 15 minutes there. Next part, we want to determine the constant speed of the car during stage 2. Now, during stage 2, at the start of stage 2, the car is 40 kilometers on its journey. The town is at 100 kilometers. So we can look at this in terms of drawing a triangle. Let's draw a triangle so we can see it clearly. A right angle triangle for that matter. So here's a right angle triangle. And we can see here that the rise in our triangle is 10, 20, 30, 40, 50, 60. That's 60 kilometers. And the run on our triangle, each of these is 15 minutes. So it's 15, 30, 45, 60. So that's 60 minutes or 1 hour. Now it says determine the constant speed of the car during stage 2. The question does not tell us to use kilometers per hour or kilometers per minute, but 60 minutes is 1 hour and it has traveled 60 kilometers. So using speed equal distance over time, we can say 60 kilometers over 1 hour, which gives us 60 kilometers per hour. So that would be our speed during stage 2. Or you wanted to divide it by 60 by 60, in which case it would go 1 kilometer per minute, depending on how you wanted to calculate it. The question did not say. The last part of the question now is to calculate the average speed of the car for the time during which it was moving. So the car is moving here, the car is moving here, and the car is moving here. So what is the total time for the journey in which the car was moving? Remember, speed is equal to distance over time. Now, the total distance for the journey, it takes 100 kilometers to reach. So the total distance would be 100 to go and 100 to return. So that's a total of 200 kilometers. Now let's look at the time, the total time. While it's moving here, it's 15, 30, 45, 60, so that's 1 hour. It's moving here, that's another hour. And in returning, starting from this point to that point, the total time would be 1 hour and 15 minutes. 1 hour and 15 minutes. 15 over 60 is the same thing as 0.25. So what we have here is a total of 200 kilometers divided by 1, 2, 3 hours and 3.25 hours. And dividing 200 by 3.25 gives us 61.54 kilometers per hour. Distance time graphs can be fun, they can be easily understood, and they can be easy to manage. You may want to watch this video again if you don't get it the first time. Remember, you can find more practice material at csecmathtutor.com in the paper 2/3 section, or you might want to use the past papers, or you might want to use the multiple choice papers. There are many, many practice papers there for you to look at and to use to improve your skills. Remember to subscribe. Remember to share with somebody doing the exam. Continue to learn and grow, and best wishes as you continue to prepare.